Quantities and units. The SI units that are commonly used in mechanics are, for mass, the kilogram, symbol kg, length or displacement, we use the meter, symbol m, and for time, the SI unit is the second, symbol s. These are known as base units. There are also derived units which are made of a combination of these base units. These are known as derived units, as mentioned above. Common derived units that are used in mechanics are speed or velocity, which is in meters per second, so we can see that's a combination of length and time. And we write ms-1 or sometimes m/s. Acceleration is in meters per second squared, or meters per second. That's meters per second squared, as we can see here. And once again, that's a combination of length and time. Weight or force is in newtons, and the symbol for that is N. So let's just look at these units a bit more. So consider that velocity is distance divided by time. If d is measured in meters and time in seconds, then in terms of units, what we have are meters divided by seconds, which is how we get the unit meters per second. If d is measured in kilometers and time in hours, then we get kilometers per hour. But meters per second are based on the SI units themselves. Consider that force is equal to mass times acceleration. We have seen that the unit of force is the Newton, N. But if we use SI units on the right-hand side over here, so we have mass times acceleration, that's mass times the change in speed or change in velocity divided by time. So mass is in kilograms, the speed would be in meters per second, and then we divide by seconds, which gives us kilogram meters per second squared. Note that weight is a force, so the unit of weight is the Newton, not the kilogram. A kilogram of sugar on the Earth would still be a kilogram of sugar on the Moon, because kilograms actually measure the mass, the amount of the substance. But it weighs 6 times as much on the Earth.